Powerful collaborations, cutting-edge science, and curious minds coming together for a glimpse of the future. Stay tuned as we look at the latest updates on some of the most promising technology projects. Hello and welcome. I'm your host, Peter Ballant from Technicon. In this final episode of the AQUARIUS podcast series, we look again at the testing of the prototype. A valuable consortium member for this purpose is industrial partner OMV. They are well equipped to evaluate the sensor which has come out of AQUARIUS. It's early yet, and there is still much work to be done, but having a prototype like this is great news for AQUARIUS. It brings us one step closer to finding contaminants in water, inline and online, meaning the process is done on site, not in a lab. In today's episode, we speak with Christoph Puls from OMV. He is involved in the day-to-day when it comes to testing the prototype. Thanks for joining us today.
Yes, thank you.
In the last few episodes, we learned that AQUARIUS was a project which ultimately contributed to clean water through advanced sensing techniques. Can you tell us what OMV's role is in AQUARIUS?
As an industrial partner, OMV was leading the testing and validation of the developed online sensing system. Our water treatment plant in Schönkirchen in Lower Austria, which was refitted in 2015, has a capacity of 10 million cubic meters of water per year and is located conveniently near our tech center and lab. Accordingly, we have the possibility to test the developed system using water streams in different stages of a cleanup process and can evaluate the system's performance in a broad range of application levels. Due to the nature of our produced waters, these represent rather harsh operating conditions for the AQUARIUS prototype, and we were able to point out a multitude of enhancements for the system to increase reliability and, as a direct consequence, decrease maintenance costs for future users of AQUARIUS systems.
And are you able to predict the length of time between the testing phase, which is right now, and the point where a marketable product can come out of AQUARIUS?
No, since the development of a system from prototype to a commercial product can be quite time-consuming, I would not predict the time span. Of course, this also depends on the implementation of potential improvements, and this lies in the hands of our partners from Quantared, with whom we have close ties concerning oil and water analysis.
Okay, but when these AQUARIUS technologies do reach the market, how could OMV benefit from them?
The AQUARIUS system offers continuous monitoring of water quality, and its detection strategy is close to established system used offline for monitoring by laboratory measurements. As a direct consequence, the results given by the new system are closely related to our own reference analysis, and by design, they are really robust against a multitude of analytical interferences and fluctuating oil compositions we encounter in our daily work. When deployed, the AQUARIUS system could offer reliable monitoring data with a time resolution and response time that cannot be achieved by offline surveillance via laboratory analysis. This can provide valuable information on plant performance, especially if the specific point in time of fluctuations, as an example, can be related to certain operating or influx conditions like upstream maintenance works.
I see. Can you tell us how the new sensing technologies were tested by OMV?
Yes, the prototype was hooked up to different streams in our water treatment plant, and our main goal were to evaluate sensitivity and accuracy, of course, which was achieved by comparing the results given by the AQUARIUS prototype to analysis results of parallel samples taken to our tech center and lab. When available, the results were also compared to other data to evaluate the fluctuations. Due to the environmental conditions we encountered, especially in the heat in summer, we encountered several issues related to measurement stability and robustness. This was rather unexpected, but those issues could be solved in close cooperations with our partners from Quantared. Due to the ongoing corona situations, this was not easy, but I got used to being remote controlled by Quantared for the manual work, while they could monitor the instrument performance and update the software remotely.
Mm-hmm. It makes sense. And from your side, what would be considered a success in AQUARIUS?
A success would be the development of a workable and robust online sensing system for oil and water. This would be a great first step in direction of the kind of analysis system we target with the project. Since there are already commercial systems for oil and water monitoring on the market, we would of course target high sensibility and especially a high selectiveness to minimize wrong readings by interfering water constituents or other changes in the sample stream.
Mm-hmm. And can you explain how water is used in the process of oil and gas production and why it's so important that its quality is closely monitored?
First of all, I have to say there that in oil production, we are dealing with a closed circuit of water. That means that no contaminated water is discharged into the environment. The water that is produced alongside the oil is, after treatment, re-injected into the oil reservoir to maintain its pressure and to increase the oil recovery. To achieve this re-injection, we need to clean up the water to a high degree since we are basically pumping it into a porous rock phase, and insufficient quality could lead to blockage of the injectors, and those would require workovers to restore the injectivity. If this injectivity cannot be maintained, we have to reduce our productions by the same extent.
And was there an aspect of the Aquarius project that did not go as planned?
Yes, we had a couple of setbacks in development and production of some of the novel optical components required to achieve the targeted system performance. But most of the testing period had to be done using alternative components. But that did not impact the performance testing concerning the robustness of the overall system, especially a sample introduction and extraction unit. At the very end, we were able to also assess the newly developed spectrometer under real-life conditions in the field, which was why we joined the consortium at the very beginning.
Well, it's very interesting to find out your role in the project, and the project is almost done. So we wish you success all the way up to the very end. And we thank you especially for coming on today and talking a little bit about how what you're doing is developing technology in the European Union. So thank you.
Yeah, thank you. And thank you for having me in this podcast.
If you'd like to see more about Aquarius, check out their website at aquarius-project.eu. This podcast has been brought to you by Technicon. The project leading to this application has received funding from the European Union's Horizon 2020 Research and Innovation Program under Grant Agreement number 731465. This project is an initiative of the Photonics Public-Private Partnership.